What is the brightest object that exists in the entire universe? Apparently magnitude, then. Frequently used to describe stargazing how bright a thing is if we were to look up from Earth, it would seem to us. Various Earth-centered factors are involved, such as how near the object is to the Earth. Logarithmic magnitudes are used. Is set up like golf, with a lesser number of players signifies a brighter light. But now absolute magnitude is what I'm after. An indicator of how bright everything is overall. The universe is close and would be if we were to look at them from the same vantage point. Hello and welcome to KYC News, and please don't forget to subscribe and hit the bell icon. Quantity will serve as a reference. The most dazzling us despite appearing weak, there is light in the universe, simply because it is distant from us here on Earth. The variation is substantial. A light bulb of 100 watts positioned approximately 8 centimeters or closer from your eye, 3 inches, will appear in the sky as being brighter than the sun. However, that is unfair. If you could see the sun and the light source, the sun would be visible at the same distance if brighter by a septillion times. Oh, that's nice. Nonetheless, sun compared to the rest of the cosmos glows insignificantly. If you could position the sun so that all other alternatives offering cosmology and each star phenomenon, the sun's absolute magnitude offers a good chance. The number 4.8. Very good. But look at our 13601. This nuclear-powered monster is not the largest star, although it is just 256 in size. Tens of times as large as our sun. It is the largest star. It is the brightest object ever discovered. Keep in mind the lower absolute magnitudes are more visible. Not our 13601 is 4.8, it is minus 12.6 like our sun. The brightness is 8.7 million times greater than our sun. But our 13601 is not the smartest thing there is. A massive star explodes fiercely when it dies, in a phenomenon called a supernova, like a hypernova. Like I said in my video, how warm can it be? Supernovas can release frightful flashes of light, known as gamma-ray burst radiation. Arguably, the most brilliant electromagnetic phenomena in the cosmos. As much energy as a typical gamma-ray burst releases in a few seconds, as much energy as our sun will be released in its entirety. Lifetime of 10 billion years. If WR104, a potential gamma-ray explosion, was directly hit only 10 seconds with such a laser on Earth, astronomers estimate it might use about 25% of our resources, ozone layer, and cause a widespread extinction of species and famine. The largest nuclear weapon to have ever been detonated did not act in a manner similar to that, and did right explosion in our atmosphere, here. However, WR104 located 8,000 light-years distant. It isn't even visible to the unaided eye. A set of binoculars, perhaps. Gamma-ray bursts, however, are only fleeting occurrences with a maximum duration of a few minutes, occasionally within a few milliseconds. If you desire the best, you'll have to look, oddly, for a sustained item in the darkest situation. Dark spheres. Fair enough, dark matter is supposedly darker. However, given that dark matter has been proposed not even to interact with electromagnetic fields or light, calling dark matter not brilliant in any way is comparable to referring to your peanut butter sandwich. A slow airplane. It's not even truly in the same class. However, black holes do interact with light. They don't let any because they reflect so little. Escape is not possible, at least not in the same way. It entered. That is dim. However, the powerful energies produced by dark holes in the eating process, such things as stars, is not at all dark. From the stars they consume, gas and debris whirl into accretion disks, also known as the Arsopluvian cosmic gallows, before taking their ultimate leap to death into the abyssal void. Debris in the disk rotates at unfathomable speeds. Accelerated, being dragged around by a black hole a billion times greater magnitude, unlike our sun, heat is produced by friction in the accretion disk, on a level that is challenging to completely comprehend. The disk glows in the same way as hot objects do. It has a name because it is so vibrant. The quasar. Quasars are hundreds of times brighter than stars. Even brighter than stars. Joking aside, it's frightening. The net quasars are hundreds of times brighter than stars, compared to galaxies with billions of stars. 3C273, the first quasar discovered, has a magnitude that is absolute, which is minus 26.7, making it brighter than our sun by a factor of 4 trillion, 100 times brighter than the sum of the lights produced by the whole Milky Way. When entering 3C273, it would be 33 light-years away from us. As brilliant as our sun, 8 light-minutes at most. Using the corona to dim a quasar's brightness graph indicates the existence of quasars in the galaxy centers that, despite being smaller in size than they are overwhelmed by their radiance. Active galactic nuclei are these galactic centers, the majority of their energy erupting the shape of a strong radiation jet, length of which evens out to dishonor our solar system. The jet's apparent component, taking this image as an example, long enough to reach the sun 1.5 million times around Pluto. Specifically, if a significant amount of this energy is projected at Earth, it is the cause of what we refer to as a quasar. However, if Earth in the active views of the galactic nucleus, it goes by the spookier name of a blazar. Additionally, blazar 3C454.3 was the timer, and the brightest radiance ever noticed. It reported in at historically high activity levels and minus 31.4 in absolute magnitude. To calculate the quasar brightness, look at it from still another angle. When it occurs 100,000 times taken by the Hubble telescope in this image. A few hundred light years away is this star, and this object appears to be nearly as bright. However, it's a quasar, 9 billion light years from Earth. How come quasars are so far away? A quasar, however, is not eternal. Billions of light years separate them. It indicates the light we get from the images we capture of them are images of events in progress few billion years ago. They reflect a more typical phenomenon. When the universe first began, monster black holes were still unfed. All the stars around to stoke their and accretion disks before they grew to be too large to function. According to Neil deGrasse Tyson, in order to maintain for a black hole to produce quasars, it must eat them. Roughly 10 stars per year. Many devour 600 stars, more than 1,000 a year. Each and every minute, the equivalent of the Earth. A greater a black hole devours stars, the farther away its event horizon is until someday it stops tearing the stars apart. A disk's accretion fuel. Instead, it simply suffocates them whole. In a single, eerily dim, yet scary gulp. One of the most common types of in our cosmos, there are old things. If you could teleport to one right now, in an instant it would probably travel faster than light. Not be burning anymore. What we notice simply their ghosts. Leaving light when they were activity that went farther than they could go in one lifetime. Quasars can still be born, though. Even children can be born. In reality, this place. In my movie What Are We Missing? I emphasize that the galaxy Andromeda is moving toward us. The two will meet in 3 to 5 billion years. With the Milky Way, our own galaxy. The collision is also could reorganize stars close to the consumption of galaxy-centered black holes, rekindling a quasar in this location, in our galaxy. Funny thing is, not many of us even see Andromeda, despite the fact that your unaided eye is what we require. The night sky is drowned out by light from our cities. A quasar obliterates its host galaxy. Artist large cities were imagined by Thierry Cohen. would appear if each of their lights off and they could see the sky above them. Fully. New York, Shanghai, Hong Kong, Los Angeles, and Tokyo. It's lovely. Rare, also. 1980s and 1990s, during a Los Angeles citywide blackout, a number of homes actually contacted the cops apprehensive of eerie shimmering clouds hovering over the urban area. They could see for the first time in their life our galaxy. Artificial lights enable humans to see at night what's around, but we fall short the thing above us. The most brilliant areas have the most desolate, empty sky. Once more, we have yin and yang. A Taijiquan has in fact been present in this video. Every moment. The universe's brightest objects, quasars, are brought on by the universe's darkest elements, dark spheres. The technique that releases the most light is brought about by the thing that best confines it. And as usual, thank you for your time.